The Al-Ez Steel Rebars Company mini mill, supplied by Danieli on a turnkey basis and located in the 4th Industrial Zone of Sadat City, Egypt, includes a 600,000 ton per year melt shop and 2 rolling mills, each one designed for producing 350,000 tons per year of rounds and rebars in a range of 10 to 32 millimeters. The melt shop, which is prepared for charging pre-produced iron, is produced mainly low and medium carbon steels and is fitted with one 95-ton electric arc furnace, one ladle furnace, and one 5-strand continuous casting machine. The 2 rolling mills feature the same characteristics and produce the range of rounds and deformed bars using the slitting technology from the smaller sizes. This complex is provided with 3 water treatment plants, 2 of which are for the rolling mills and 1 for the melt shop. A fume dedusting plant with a capacity of 1,100,000 meters cubed per hour sucking from the canopy hood and from the primary sucking line are equipped with a hairpin cooler. Scrap is unloaded from trucks into one open yard storage area where a scrap quality selection is made, dividing into several categories according to its density and carbon content, such as heavy melting, bundles, turnings, plate scrap, cast iron, etc. The scrap density can be assumed as 0.7 tons per meter cubed. After the selection, the scrap is stored in the scrap yard by service cranes. In this way, the furnace can be constantly charged with 2 buckets of pre-selected scrap. The 2 buckets are positioned on bucket cars and are charged simultaneously by cranes of 16 tons capacity equipped with grab or magnet. The cranes can be radio remote controlled. The buckets are also constantly weighed by means of a weighing system installed on the transfer cars. Afterwards, the scrap is charged into the electric arc furnace, the nominal capacity of which is 95 tons of tapped steel. The furnace is equipped with auxiliaries such as oxy-fuel burners, oxygen lance and carbon injector in order to facilitate and improve the melting operation. Additive charging system configuration foresees additive feeding in the electric arc furnace through a 5th hole and directly into the ladle. Liquid steel is poured into the preheated ladle located on the ladle car, and the weight of steel is controlled by a weighing system. After this stage, the ladle is transferred to the ladle furnace. At the end of this treatment, the ladle is sent to the Conti caster ladle turret. The machine consists of a 5-strand Conti caster, 7-meter radius, 2 tundish cars, hydraulic cutting shears, and a collecting table. The caster machine can cast billets from 100 to 160 millimeter sections with a maximum length of 12 meters. Billets are cut to length and stored in the appropriate area. From here, they can be sent to the reheat furnace by means of the crane. The various phases of the production process are controlled by an automation system. Both Both bar mills produce low and medium carbon steel bars in 10 to 32 millimeters. The starting material consists of 130 millimeter square billets, measuring 12 meters and weighing 1,550 kilos. Each rolling mill is fed by a 70-ton per hour walking hearth reheating furnace, supplied by Danieli Centro Combustion. Each rolling mill is composed in horizontal, vertical, and convertible Danieli ESS compact cantilever rolling stands. These stands allow quick changing of rings and guides using the sandwich ready-to-roll concept for producing any size included in the production mix. The walking beam cooling bed measures 66 by 9.5 meters. The cold finishing facilities include a 330-ton reciprocating shear for cutting to length and automatic systems for counting, packaging, bundle tying, weighing, and collecting. Billets, coming from the warehouse, are fed into the reheating furnace. The 70-ton per hour furnace is divided into 3 heating zones with independent adjustment. This allows the heating process to be optimized in terms of minimum scale losses, high thermal efficiency, and flexibility. Only one operator is required to manage the furnace charging, heating, and extraction phases, thanks to the process automation and control system by Danieli Automation. The roughing mill is made up of ESS stands with cantilever rolling rings having nominal diameters of 585 millimeters and 450 millimeters. At the roughing mill outlet, a 40-ton crank shear performs head and tail cropping. Bar tension control between the roughing stands is assured by an automatic pull control system. The intermediate rolling mill is made up by ESS stands with 450 millimeter diameter cantilever rolling rings. The finishing mill consists of ESS stands, 345 millimeter diameter, with cantilever rolling rings which allow the rolling mill to be adjusted to the best possible roll-pass design. Thanks to the slitting technology, 10 to 12 millimeter round bars are rolled on 2 strands in order to reach hourly productions equal to those of the larger sections. The intermediate and finishing mill are served by an automatic loop control system. At finishing mill outlets, the roll stock is divided by a flying shear. Cutting to multiple lengths is programmed and optimized according to the commercial length of the product. The whole rolling process is controlled by a fully integrated automation and control system supplied by Danieli Automation, which allows the operative staff to be reduced to 6 people directly operative in a shift. The rolled stock is cooled on walking beam cooling beds, where the bars are unloaded at a maximum speed of 16 meters per second from a roller table with lifting aprons. At the cooling bed outlet, a system of lining up rollers and trolleys prepares the layer to be forwarded to the reciprocating shear for cold cutting to length. An automatic bar counting system allows to predetermine precisely the exact number of bars for each bundle. The bundles are tied by 2 automatic wire binding machines. The bundles are then weighed and forwarded to storage. All cold finishing operations are managed in an accurate and flexible way by the process automation and control system. The water treatment plant plays an extremely important role in productivity and production quality. The large cooling requirement during steel production and rolling involves the circulation of large water quantities delivered by pump units dedicated to different circuit types. Indirect circuit water is not made dirty during the process. It is cooled directly in the evaporation towers and then recirculated. For instance, here you can see cooling towers of melt shop indirect circuits. In blackout conditions, for cooling the electric furnace and the Conti caster, an emergency piezometric tank with 180 meters cubed capacity is provided. Direct circuit water, on the other hand, is largely made dirty with scale, calamine, oil, and grease, thus requiring special cleaning before recirculating. After collection in the scale pit, where most of the scale produced during the process is removed, water passes through a longitudinal sedimentator. In this section, a thinner scale fraction is further produced, and oils and greases are removed. This fraction is collected in a dedicated final tank section. Final water cleaning is performed by means of quartz sand filters, producing high-quality water. In the end, clean water is cooled in evaporation towers and then sent back to the complex. Each of the 3 water treatment plants is provided with its own control room fitted with man-machine interface for displaying the proper functioning of the plant and for setting the desired parameters. A single fume plant is provided to treat the fumes produced during melt shop operation by the furnaces. The primary fumes are sucked from the 4th hole on the electric arc furnace roof through a water-cooled elbow duct. The fumes are collected in the elbow duct by mobile water-cooled ducts. One hairpin cooler is installed to close the bag filter to separate positively ignited coal particles and coarse dust from the fume stream and to cool down the fumes. The secondary fumes emitted during tapping and scrap charging are sucked by a hood installed above the cranes on the bearing structure of the building. The primary fumes extracted from the 4th hole of the furnace are mixed with the secondary fumes coming from the canopy hood. The fumes are filtered by a pulse jet bag filter. Bag cleaning is performed by compressed air jets. This cleaning system assures the best yield achievable with this type of filter. 3 centrifugal fans installed after the filter suck the fumes from the whole circuit and deliver them to the stack. The total exhaust flow rate is regulated by an automatic system adjusting the position of the valves and dampers of the fume circuit according to the required suction rates. Alez Steel Rebars is one of the most important Egyptian producers of steel bars. With its new Danieli mini mill, it further strengthens its position in the domestic and foreign market towards becoming a production cost winner.